Welcome back to my mini project, that is AI powered expense anomaly detector. Now you can browse the CSV files or we can drag and drop the files here. I have two files and I will be showing the insights of this. So this is the first one where I have kept less records. So here there are only 7 records and the one with at least 17 records, and how they affect the insights we will discuss it in the later part of this video. And they have 4 features you just saw. So let's go one by one. So I dragged the first one with lesser records. Now let me show you the flow of the app. So filter, you can filter by date range, you can filter by category, and mainly where I want to point out is the Z or Z score anomaly detection and the one with the isolation forest. So for this data set, the Z score, it detected 2 anomaly, that is one is 8000 and another is 5000. And why this is so, I will be discussing in depth. Whatever I have learned, this is my learning journey and I will be discussing, I will be giving you all the insights from my side. So the left side is for Z score daily expense, you can see, and the right side, the plotting, is for isolation forest for daily expense. So these are two, and here there is a table in the form of table. This is also being presented, and for this app there are 2 more tab. You can see one is insights, and this insight is for the spending by category and spending by payment method. This is also helpful, and finally you can download whatever anomalies are there and you can present, or we can present rather, to whom it is concerned. Now here category I am not discussing that much, so if you add more categories it will reflect, the graph will reflect that, and if you are removing accordingly you can see the reflection of the anomalies according to the category. So now let's discuss about this threshold. So once I am increasing the threshold, now it's 4, see the 5000 anomaly is gone. Why it is gone, we will discuss it in the later part of the sharing. So you can adjust the threshold and it will be reflected on the left side of the plotting, that is for Z score plotting, right? And here I have used robust Z score for detection. Why robust? We will also discuss on that. Now let me drag and drop the second one where we have 18 records. So here is the detection part. So it has detected, the Z score has detected 4 anomaly. Now Z score based on deviation from median and isolation forest, median learning based anomaly detector. Now Z score is a statistical technique and isolation forest is an ML technique. So I have used two to learn more about this. Now you can see that the anomaly point, they have increased and there are few anomaly points with very less amount like 450, 270, and why they are so, that also I have found or I have detected also with questioning. I have taken help of chat GPT and Google. So from there whatever I have learned I will be showing, I will be presenting to you. So for Z score there are 4 anomalies, for isolation forest there are 5, and I have used PyCharm. The coding will be given in the GitHub. So I will share my GitHub repository link with you so that you can also copy and you can do further analysis with this, because this is a very basic one and I know that further analysis could also be done, so you can use that. And see, this is my GitHub account, so the link will be there and you will get the much details what I have, I will share with you. So welcome back again with my mini project. So today I will be sharing my learning and a short, you can say, analysis or insight of the project, that how I found it. So this is the first data set I showed you earlier. So here the robust anomaly detection is on this amount feature or the amount column. So it's calculating the median and MAT with this formula. Now I took the help of ChatGPT and Google also. So I asked why use median and MAT for z-score instead of the traditional mean and standard deviation, and I came up with the answer this: because median and MAT are most robust to outliers and we are trying to detect outliers. Now traditional z-score, that is not robust. So problem with this is, if the dataset already contains outlier, the mean and standard deviation get pulled towards those outliers, which hides the real anomalies. And this robust z-score which is used in this project, the advantage with this is median is not affected by extreme values, those are the outliers, and MAT also stays stable even if a few extreme expense exist. Now let's move further. So here is the calculation which is done, and my app is using basically the threshold of 3 or 3.5, and it is showing you accordingly. Now this is the one where I have included the outlier and where it found the anomalies, and here you can see it's 8,000 and 5,000, these two anomalies it detected for this small data set. And this is the one, a screenshot from my app you saw just earlier. Now this is the second data set amount section, and this is the calculation part, so you can just pause and see to it. I have included it here, and this one is the outcome, that 1000, 2000, 5000 and 8000. These are the anomalies for z-score robust it detected. Fine. And this one is the screenshot from my app, where you can also see the red dots where the detection is done. Fine. Now the feature, we know that amount is only used and the rest of the features, category, payment method and date, are not used. We could have included it, so it can be a future proposal. So both methods in the app, robust z-score and isolation forest, analyze anomalies based on how unusual an expense amount is compared to other amounts in the dataset. And here you can find the example. We will also see to it in more depth. Now apps feature key features for isolation forest. Till now we discussed about the z-score, the much I digged out the insights I shared with you. Now basically here the amount is the feature, and the second one for this isolation forest, one hot encoding for category feature is done, and with this amount and category, these two features, this graph is plotted. Okay, now let's see one by one. Let's do the case study. Now for case 1, suppose rupees 2000 for category travel. So what happened to it? This amount fits the typical pattern in the travel category. It's not far from travels category median. Now there are other travel amounts, like there is 600. So 2000 may seem normal given travel is often a high cost category. That's why the result is not flagged as an anomaly. Now you can see in the right hand side, 2000 is not flagged as anomaly, though 1000 is flagged as anomaly because of this one hot encoding of the category feature. Now the second case and the third case, where we found though 270 is a small and minimum amount and 450 is also one minimum amount till it is flagging it as anomaly. Why? Now these categories usually have low counts in the dataset, few rows. 270 might be the only value for utility, so the model can't understand what's normal. Similarly, rupees 450 for fuel might appear far from the small group's median or just fall into the sparse pattern. Now you can see these two as anomaly is detected in the right side for isolation forest. Okay. Now the result is flagged as anomalies, simple, and the reason sparse category and isolated pattern. So these two are the reasons. Now coming to the fourth case, here 1000, 5000 and 8000, 1000 for food, 5000 for rent and 8000 for electronics. So these three are categorized as anomalies. Now let's see. The model sees similar entries for these categories. The median for electronics or rent might be high, so they don't appear strange when combined with one hot encoded category. So the result sometimes flagged or sometimes not, depending on the category distribution. And the dataset data may appear because of the small dataset. It may show sometimes and may not show sometimes. The behavior may change at different point of time. Okay, depending on the category, depending on the size of the dataset. The one I felt so I am sharing with you. Now why this happened? Isolation forest behavior. Now we know sparse categories, extreme values, deviation from category median. So if the false positive like 270, we can reduce it by further coding, making it fine tuning, and we can tune the contamination and model features. Contamination, you will find it for the isolation forest where it is calculating the, you will find one user defined function, one of the py file where it is detecting, right? So here we have used z-score and isolation forest, and here what I got the answer I have presented in front of you. So you can just wait for some time and you can see and you can go through. So this is my mini project. I learned something from it and I have shared with you, and I know there is a lot more scope to improve this one, and all the code you will find in my GitHub. So I will give that link also in the description so you can see the GitHub. For today this much. Again I will meet you with a new project. So stay tuned.